Hey everyone, with just this battery, I'm going to turn it into a DIY antenna. Let's get started. I start by lightly sanding both ends of the AA battery with sandpaper to reduce the slick surface. The reason is that a smooth surface makes soldering the copper wire difficult. The solder won't stick well, the connection becomes unstable, and the signal could be affected. Next, I use a clamp to hold the AA battery upright, then set it aside, as it will be used shortly. Next, I will cut 2 short pieces of wire. This is a basic preparation step for making the antenna whiskers. You can estimate the length by looking at the video demonstration. It doesn't need to be exact, just long enough to attach to the battery and bend later. When cutting, make sure the cut is clean, without fraying or separating the small copper strands inside, as they are delicate. Before soldering, I apply soldering flux to the wire and battery terminals to clean the surface, ensure a strong, stable joint, and reduce the risk of overheating. An inspiring true story about welding is Stefan Bryla, a Polish engineer who built the world's first welded road bridge in 1929 in Morzys, Poland. This bridge shows that welding is not just a craft, but also crucial in modern construction and engineering. This story reminds us that learning welding is very useful. It helps join materials securely and opens up many career opportunities. Try learning welding to create useful projects and explore your own potential. That really shows that having soldering skills is an essential thing. With the 2 pieces of wire I just cut, I will set them up like this. I'm leaving them like this just to make soldering easier. Next, for the copper core of the wire just cut, I use a soldering machine to melt a zinc rod and attach it directly to the exposed copper strands. This step is crucial for creating a strong connection between the wire and other parts of the antenna. When heating the zinc, it's important to maintain the right temperature. Too hot can burn the insulation, too cool, and the zinc won't stick well to the copper strands. I move the soldering tip evenly, allowing the zinc to flow into each small copper strand, fully covering the exposed core, creating a uniform, durable, and conductive joint. This ensures that when the antenna operates, the electric current flows smoothly through the copper wire, improving signal reception. The solder also keeps the strands together, preventing them from fraying or tangling, which is important for shaping the antenna whiskers later. This is a simple but essential step in making a DIY copper wire antenna. With the soldering done like this, it's finished, and I'm ready to move on to the next step. Now, remove the outer insulating layer. At this step, we will connect the electrical wires. I already bought a fairly long piece of TV antenna wire this morning to make filming the video more convenient. You have a measuring ruler there, right? Please measure a piece of wire about 30 centimeters long, which is equivalent to 11 and 13/16 inches. Use the knife you have and follow my movements if you are a beginner with no experience. In this part, I will stay silent so you can focus better. One end of the wire is connected to the shielding layer the TV antenna wire just cut, leaving a small section of shielding as instructed. The other end is connected directly to the copper core of the TV antenna wire. Once the solder joints are complete, I wrap black electrical tape around the ends to protect them, ensuring safety and preventing short circuits. This keeps the antenna both sturdy and safe to use. Next, I will bend the top end of the copper wire into the copper core of the TV antenna, ensuring the two parts are securely connected, creating a stable joint for better signal reception. Once the end is fixed, I use a cone-shaped drill bit to help shape the copper core. By threading the wire around the drill bit and rotating gently, I form a uniform cone shape, making the antenna whiskers balanced while also improving signal capture. After the copper wire takes the cone shape, I remove the drill bit and the wire retains the shape created. This ensures the wire does not deform or bend unevenly, maintaining straightness from the battery connection down to the antenna whiskers. The cone shape is not just aesthetic but also functional. The twisted loops of copper increase the surface area interacting with signals, enhancing the antenna's reception performance. This step requires patience and care. Rotate the drill slowly, maintain even pressure, and watch the loops carefully to avoid overlapping too much. When completed, you'll have sturdy, balanced antenna whiskers optimized for TV signal reception. Next, I will use a pull tab from a Coca-Cola can as the tip of the antenna whiskers. The pull tab is small, lightweight, and circular, making it ideal to attach to the top end of the copper core that we just shaped into a cone. Connecting the pull tab to the antenna whiskers not only reinforces the tip, but also helps the antenna receive signals more effectively, as the metal of the tab adds extra surface area for electromagnetic waves. I will solder or secure the pull tab carefully onto the copper core, ensuring it doesn't loosen or tilt. Once attached, the tip of the antenna whisker is sturdy and balanced, maintaining the cone shape we created. The tab also helps distribute weight evenly, preventing the wire from bending or leaning, and provide a clear, safe endpoint for the antenna whisker. Finally, after all the components are prepared and secured, we connect the final cable segment to the antenna joint. This is the finishing step that makes the antenna continuous and ready to connect directly to a TV or signal receiver. The connection should be firm, tight, and stable, avoiding loose wires or poor contact, ensuring the antenna works efficiently. Once connected, the entire antenna structure, from the battery, copper core, cone-shaped whiskers, to the pull tab and cable, is complete and ready for use. Do you have doubts about this device? In fact, even after making it, sometimes we're not sure it will work as expected. So now, we're going to take the antenna out for testing to see how well it receives signals. This is the most exciting part, seeing the real results of what we just built. Currently, my TV screen is showing no signal. I'm going to plug it in to check the effectiveness of this device. And finally, after all the careful steps, our DIY antenna works beyond expectations. In direct testing, the TV signal is clear, stable, and especially, the reception strength is noticeably better than many conventional antennas I've used before. From the AA battery, multi-strand copper core, cone-shaped whiskers formed with a drill bit, to the pull tab on top and the final cable connection, everything comes together perfectly, creating an antenna that is not only durable but highly effective. The most interesting part is that every component has its own purpose, not just for decoration. The remaining shielding on the TV wire stabilizes the signal. The multi-strand copper wire allows bending without breaking. The pull tab increases surface area for signal capture, and the black electrical tape protects solder joints, ensuring safe usage. All these factors combine to make an antenna that is both reliable and highly functional, proving that you can successfully create an effective electronic device at home using simple materials. I truly encourage everyone to try this themselves, not only to learn soldering, wire joining, and metal bending skills, but also to experience the joy of building a device that actually works. It's thrilling to watch the signal improve and channels appear clearly in real time. This is the joy of DIY. Making it yourself, testing it yourself, and seeing the results yourself. If you found this video helpful and enjoyed this DIY antenna project, don't forget to like, subscribe, and hit the notification bell so you won't miss future tips and projects. Every like and subscriber gives me more motivation to share other exciting ideas, turning simple everyday materials into fully functional electronic tools, bringing joy, convenience, and endless creativity